So today we're going to learn about transforming random variables and the impact that transformations will have on measures of center, measures of spread, that kind of thing. So we have an example here that you can read through, but basically we are presented here with a table, a distribution table, that presents the number of units that students take and the probability for each of those number of units. So if you kind of look across, you can see a lot of people take 12 hours. The majority, the highest proportion falls with 15 hours, that kind of thing. So we want to go ahead and calculate and interpret the mean and standard deviation of x. So expected value of x is equal to the mean of x. And make sure you know x is the number of units taken. So before you start computing anything with it, you need to make sure you identify the variable always. And I'm simply going to set this up, and I'm going to show you how to do it in the calculator real quickly. So it's going to be 12 times 0.25 plus 13 times 0.10 plus, and I'm just going to do dot, 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 plus, and this is just an ellipsis saying to continue that pattern, and then 18 times 0.15, and then I'm going to get 14.65 units. Then for the standard deviation, it's a little bit more involved, but I'm going to just set up the first one, I'm going to set up the last one. So I'm going to have 12 minus the mean of 14.65 squared times the probability of that outcome, which is 0.25, plus dot, 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 plus, and then I'm going to show you the very last one over here, 18 minus 14.65, all squared, and then also multiply by its probability, and I'm going to get 2.06 units. But like I said, I'm actually going to do this in my calculator, so let me show you that. So you want to enter your data. So what I probably do now is pause and go ahead and enter the outcomes in list 1 and the probabilities for each of those outcomes in list 2, and then come back and I'll show you how to wrap this up. So I'm going to do stat calc one variable stats and list 1, list 2, and this frequency list is basically weighting the outcomes based on their proportions. And I want to calculate that and just show you. Your mean is 14.65 units and the standard deviation is 2.06 units. So that's where that information comes from. And I would strongly suggest you follow along and make sure you can do that in your calculator because you're going to have to do that on the test. Okay, so let's interpret what we have just discovered. The average number of units a full-time student takes is 14.65 units with a standard deviation of 2.06 units. So you know on average they take 14.65 units, and which means we saw that 15 was kind of the highest proportion, but it's a little bit more heavily weighted to taking less hours, which kind of makes sense. But the standard deviation is also important, and it tells you the average deviation of units taken from the expected value of 14.65 units. And you want to make sure you always put whatever your units are here. So the value of 2.06 units is the average deviation of units taken from, that's like how far they are from the expected value of 14.65 units. Okay, now we have to pay tuition on these units, so let's go down and kind of do that. So we're going to pay $50 per unit. That's actually a pretty good rate there. So you want to make sure you identify T equals your tuition paid. And you also do want to look at it in the context of how it's being transformed or how x is being transformed, and it's just 50 times x. So let's go ahead and calculate the mean and the standard deviation here, and I want you to remember 60 is just going to be 12 times 50 hours. So over here, this would be 18 times 50 hours. So that's how this table was generated. So the expected value of tuition, or the mean of the tuition, is simply going to be 600 times 0.25 plus 650 times 0.10 plus plus 900 times 0.15, and that is going to give us 732.50. Now I want to kind of note here that this is really the original 14.65 units times 50. So that's really important to pay attention to right there, because we're going to kind of summarize that in just a second. Now the standard deviation of our tuition is going to be, I'm going to use my little square root symbol here. So I'm going to do 600 minus 732.50 squared plus whoops, sorry, I forgot to multiply by my probability, 0.25 plus plus, and over here I'm going to do 900 minus 732.50 squared times this probability, which is 0.15. And that is going to give me 103. So I want you to also notice here, this is the original 2.06 multiplied by 50. So you can see that when you transform the data, so you basically have the number of hours somebody takes, and you also have the number of, the amount of their tuition. It's just a simple multiplication by 50. It also impacts the mean and the standard deviation in the exact same way. So let's go and summarize this. So what is the effect of multiplying or dividing a random variable by a constant? And here our constant was 50. So let me kind of write that out. It will multiply or divide measures of center. And the two main that we talk about here are going to be mean and median. Mode is more useful or more applicable for categorical data. And it also multiplies or divides the measures of location by B. And I'm going to kind of show you what location here is. Just a reminder, location would be things like percentiles, it would be quartiles, it would also be things like the median is 1 as well. So the median is that kind of unusual statistic that falls in both the measures of center and the measures of location. So those would also be multiplied by the value of 50 here. It doesn't change the ordering. It doesn't change the location and the relative nature of the observations, but it does change the value for that 20th percentile, for example. Okay, how will it impact measures of spread? So it also multiplies or divides measures of spread. And we really didn't need this little line right here, so just take this out. But now we're going to multiply by the absolute value of B, because you cannot have a negative spread, and let's talk about what spread would be. So spread would be things like range. So these are all distances, so they have to be positive. IQR would be a measure of spread, and standard deviation. So these are the three measures of spread that we're going to be talking about. It does not change the shape. So multiplying by 50 will not change the shape of the distribution, and that's important, and I'll show you an example in just a few minutes. So in addition to the tuition charges, each full-time student has to pay $100 in student fee. So this is an addition. So here we're adding. And they're just telling us here that we take the tuition, we add $100 to get the total cost that is being paid. So you're going to make sure you know this information, and then you also want to, of course, say that cost is equal, or C is equal to the cost paid per student. Okay, so let's go ahead and calculate the mean and standard deviation of C. And one thing I did want to show you just very quickly, if I go back to my data, and this is still for the original multiplied by 50. So I'm going to take my hours here and multiply them by 50. So I'm just going to say list 1 times 50, and it will populate this field with the same information. And now I'm going to do stat calc 1 variable stats, and now I want list 3 for this. And this is just kind of confirming that the mean and the standard deviation were correct on the other one. And now, while I'm here, I might as well show you. I could also go back in, and then for list 4, I could take list 3, and I could add $100. So list 4 is my cost. So this is going to be the cost. So now I'm going to do stat, calc, one variable stats. I'm going to do list 4. And still, it's all being compared with the distribution for the proportions that were originally given. And so this is what we're going to write down in just a second. 832.5 and 102 point, let's see, 103 is where we rounded up for that. Now, you notice this went up by $100, but the standard deviation did not. So we need to talk about that. This is a little bit different scenario. So let me go back here and go ahead and calculate the mean here. So again, we want to say that cost is going to be the, C is the cost paid per student, and the expected value of cost is equal to the mean of cost, and it's just going to be 700 times 0.25 plus 750 times 0.10, and then 1,000 times 0.15, and we just saw that it's going to be 832.50. And now the standard deviation of cost is going to be set up this way: 700 minus 832.50 squared times its probability plus ... plus, and then we'll have 1,000 minus 832.50 squared times the probability 0.15. And that is going to give us 103, and we already looked at that on the calculator. So you notice this did not change from the prior example. So what is going on here? So essentially, when you add $100 to the overall cost, so you have your tuition, you add $100, it's basically just shifting all of your observations, the values 100 to the right. So it's just a shift. It's like a translation. So it is not actually stretching, compressing, anything to that nature. So it's not going to impact the standard deviation or the measures of spread. But this additional $100 will impact the mean, the measures of center. So let's kind of summarize that. So basically, what is the effect of adding or subtracting a constant to a random variable? It will add or subtracts. So it's just a shift to the measures of center and the value of A. So by A. So kind of mark this off and that off. So it adds or subtracts to the measures of center by A. Okay, now what about the measures of spread? So let's talk about that. And it does not affect measures of spread. So does not affect measures of spread. So also delete this line down here. Sorry about that. I just copied and pasted from the prior, and I don't need all those blanks. But does not affect the shape of the distribution. Okay, so let's summarize this, and I think I can help you understand something real quickly. I think this next little bit will help you. So what is a linear transformation? How does a linear transformation affect the mean and standard deviation of a random variable? So if x is transformed to a new variable such that y is our new variable, and we have a plus bx, do you see that a is just a shift, left or right? It's an addition or subtraction, okay? So this will be more like a shift, and this will be more like a stretch or a compression, just depending. So it is just it's like a line. Y is equal to mx plus b. And b in this case, you have to kind of go back to our algebra equation for the line. B is going to be whether it shifts up or down, and then m is how it stretches in terms of slope. So that's how it relates. So think of A as more like a translation and B as more like a stretch or compression. So then how would we actually use this transformation to determine the new mean and the standard deviation? Well, the new mean, or the mean of y, is simply going to be a plus b times the mean of x. So essentially, the mean of x is going to be multiplied by b and then add a, because mean is impacted by both addition and subtraction, which would be our a, or multiplication or division. So your mean is impacted by everything. And then the standard deviation of our new variable y is simply going to be the absolute value of b times the standard deviation of x. So that's how that will work. So let's kind of look at this. Verify using the cost Eldorado example. So the cost C is found using this equation. So I have C is $100 plus 50 times our original variable x, which is our number of units. So the mean of C is simply going to be 100 plus 50 times the mean of x, which was 14.65, and that is going to give us $832.50. The standard deviation of the cost is simply going to be the absolute value of our multiplication, which is 50, because the translation, by adding 100, you're not actually stretching the data out, you're just shifting it. So it's going to be 50 times 2.06, which is $103. So how are we going to use this in the context of a problem? So let's look at the next question here. Scaling a test. So in a large introductory stats class, the distribution of x is your raw scores on a test, and it is approximately normal. That's important. Has a mean of 17.2 and a standard deviation of 3.8. And the professor decides to scale the scores by multiplying by 4 and adding 10. So let's look at this. So to find the variable y, so x is your raw scores, just making sure you understand all this. And the mean of x is 17.2 points, and the standard deviation of x is 3.8 points. And y is going to represent our new scores, and specifically y is going to basically take your x value, your raw score, multiply by 4, and add 10. So that is your equation. So the mean of y is simply going to be 10 plus 4 times the mean of x, which is 17.2. So 78.8. And then the standard deviation of y is just going to be just the absolute value of 4 times the standard deviation of x, which is going to be 3.8. And that is going to be 15.2. So how are we going to use this? Well, we're going to use it to answer questions about probability. So what is the probability that a randomly selected student has a scaled test score of at least 90? So we will know the probability that a student has a score of at least 90. Well, we know our scale data has a mean of 78.8 and a standard deviation of 15. So 90 is going to be somewhere over here, so let me draw a little picture here. The mean is 78.8, and this is our y variable. So the distribution of scaled test scores is still approximately normal, because remember that adding or subtracting, multiplying or dividing does not affect the shape. So since linear transformations do not change the shape, so we know we have a normally distributed distribution with a mean of 78.8 and a standard deviation of 15.2. So I don't know the probability that a z, because we're going to convert to our z, is greater than or equal to 90 minus 78.8 divided by 15.2. So it's going to be 1 minus the probability that z is less than or equal to 0.74. And this, we're going to use table A to find that. And then that will be equal to 1 minus 0.7704, which will be equal to 0.2296. Or, so this is a probability that a randomly selected student's scale test score will be greater than 90%, so like 23% of the students made an A after the conversion. Or you could use your normal CDF, and it would be 90 to infinity with 78.8 and 15.2, and that will give you 0.2296. Now, the only way you can do this is if you have already identified the mean and the standard deviation from above, which we did that right here. Okay, you have assignment 3 to complete. You can go ahead and start it, or you can wait till tomorrow in class, but make sure you understand these concepts and come to class tomorrow ready to ask questions.